Welcome back to Cosmic Calendar, one day of the universe where one single day holds the entire story of the cosmos. Here's the truth we rarely confront. Everything you see around you was decided long before stars existed. Chosen its path. This episode challenges a comfortable idea that beginnings are loud, explosive, and obvious. In reality, the most powerful moments in cosmic history are silent. The first particles arrived with precision. From those invisible decisions emerged the entire history of Earth, its geological eras, and the fragile miracle of life. Stay with me, because what you're about to hear isn't just about particles and forces. It's about how patience shapes destiny, how order rises from restraint. The universe never rushes what must endure. If you followed earlier days of the cosmic calendar, you'll feel how this chapter connects every thread we've explored. Here's the bold idea. The universe didn't build complexity by accident, it earned it. Once you see how these first particles shaped the cosmos, you'll never look at existence the same way again. If this journey through science and the universe speaks to you, take a moment to engage. Like, share, and subscribe to Cosmic Calendar, one day of the universe. Don't miss the next step in this unfolding cosmic story. In the very first instance of the universe, reality existed in a state beyond form. There were no atoms, no structures, no Earth, no history of Earth or geological eras waiting to unfold. Space itself was saturated with raw energy, so intense that matter could not yet survive. This was the universe at its most primitive, deciding what existence would be made of. As expansion began and temperatures dropped ever so slightly, energy crossed a crucial threshold. From that seething field emerged the first fundamental particles. Quarks, leptons, and force carriers appeared not as objects in space, but as rules made physical. These particles defined what could exist and what could never be. Every proton, every atom, every molecule that would later build planets and life traces its ancestry to this moment. The origin of life, humanity, and the planet itself depends entirely on these first building blocks, forming exactly as they did. There was no room for error, no second attempt. Quarks combined in specific ways, guided by the strong nuclear force forming protons and neutrons. These were not yet parts of atoms, but they were essential foundations. Without them, chemistry would never exist and the universe would remain forever sterile. At the same time, photons flooded space, carrying immense energy. Neutrinos passed through everything almost untouched, silent witnesses to the universe's first heartbeat. Even today, those same particles still cross the cosmos, carrying information from this ancient era. What's striking is how impersonal this process was. No intention, no design, only physical law unfolding with precision. And yet from that neutrality emerged the conditions for life, meaning and awareness. In later Cosmic Calendar episodes, when we explore atoms, stars, and galaxies, everything will trace back to this moment. This is where the universe decided to be buildable. The quiet lesson here is profound. Complexity does not begin with grand structures. It begins with simple elements allowed to endure. In the seconds that followed, the universe was still dominated by energy. Heat ruled everything, and change happened almost too fast to register. Yet beneath this chaos, a transformation was underway. Energy was learning how to become something that could last. As expansion continued, temperatures fell just enough for Einstein's equation to take effect on a cosmic scale. Energy condensed into mass. Matter was no longer temporary, it could persist. This was one of the most important turning points in the history of the universe. From this moment on, existence gained weight. Matter could remain instead of vanishing instantly back into radiation. Without this transition, there would be no planets, no extreme events, no geological eras shaping Earth. This shift did not happen explosively. It unfolded through balance. Physical law allowed energy to slow, to settle, to take form. The universe was choosing continuity over immediacy. Matter began interacting under stable conditions. Forces acted consistently. Reactions followed rules. Science itself was becoming possible long before observers existed. Although the cosmos was still opaque and hostile, it was no longer fragile. Matter had secured a place in reality. From this point forward, the universe could accumulate history instead of erasing it. Later episodes of the Cosmic Calendar will show how this stability allowed atoms and light to emerge. But none of that could happen without this moment of endurance. The deeper insight is subtle. Lasting creation begins when persistence becomes possible. As matter endured, interactions between particles became more organized. Collisions were still violent, but they followed predictable patterns. The universe was no longer improvising, it was rehearsing structure. Protons and neutrons formed, broke apart and reformed again. Each interaction tested which combinations could survive extreme conditions. These trials shaped the future of every atom that would one day exist. Neutrinos continued to pass through the cosmos with barely any interaction. They carried information without disturbance, preserving a record of these earliest moments. Even now, they remain messengers from the universe's youth. Radiation still dominated energy flow, but it no longer erased matter instantly. A balance had formed. Matter could exist long enough to matter. That distinction changed everything. The fundamental forces now operated in distinct roles. The strong force bound nuclei. Electromagnetism shaped interaction at distance. Gravity waited patiently, still weak but persistent. This consistency allowed the universe to become readable. Patterns repeated. Outcomes could be predicted. The foundations of science were already in place, billions of years before humanity. When later cosmic calendar episodes explore galaxies and cosmic structure, these interactions will reveal themselves as the unseen groundwork behind everything visible. As expansion continued, cooling reshaped the behavior of everything that existed. Speed gave way to restraint. Particles slowed, interactions softened. The universe began to control its own intensity, a crucial step in its evolution. Quarks remained bound inside protons and neutrons, forming stable matter. Matter no longer dissolved instantly. Stability was no longer temporary. This persistence formed the backbone of all future structure in the cosmos. The cosmos was still dense and hostile, but it had learned how to last. Endurance replaced volatility, a fundamental shift in cosmic nature. Without this shift, planets, life, and humanity would never appear. Radiation still filled space, but it no longer dominated completely. Matter could accumulate instead of being erased, building blocks for galaxies. Chemistry was not yet possible, but its emergence was no longer forbidden. This cooling shaped how energy would later flow through stars, and how extreme events would unfold across the universe, guiding cosmic forces. Even Earth's most violent processes trace their physics back to this era. Nothing new was added here, no new forces, no new particles. Only changing conditions transformed everything. Context, not invention, drove progress. As predictability increased, the universe became self-consistent. Laws no longer shifted. Reality stabilized into a system capable of evolution. The quiet truth of this moment endures, a testament to cosmic design. Creation requires patience. The universe slowed down its frantic pace to make everything else possible, from stars to life itself. As cooling continued, protons and neutrons were no longer fleeting arrangements. They became reliable structures, repeating the same forms again and again. This repetition mattered more than scale or beauty. It meant the universe could finally build on itself, instead of starting over each instant. These particles gathered in a dense cosmic environment, where collisions were still frequent but no longer fatal. Protons repelled each other electrically, yet the strong nuclear force held nuclei together at close range. This delicate balance defined what kinds of matter could exist. Every atom on Earth still obeys these same rules. For the first time, the universe possessed true building blocks. Not atoms yet, but the components that would soon assemble into them. Hydrogen's future nucleus was already present in these protons, waiting for the right conditions. The origin of life, the planet, and humanity all trace back to this quiet preparation. This phase was brief on cosmic scales, yet decisive. If protons and neutrons had failed to stabilize, chemistry would never have emerged. Without chemistry, there would be no geological eras, no oceans, no life to evolve. The universe crossed another invisible line, and nothing turned back. Energy still dominated the cosmos, but matter had claimed a permanent role. Radiation could interact with nuclei without destroying them outright. This coexistence allowed complexity to be delayed rather than denied. The universe was no longer fragile, it was resilient. In later cosmic calendar episodes, when we explore the formation of the first atoms and the birth of light-filled space, this moment will reappear as a silent prerequisite. Those grand visuals depend entirely on these unseen interactions. Big outcomes are born from small disciplined beginnings. What stands out is how restrained this progress was. There was no explosion of complexity, only careful accumulation. Science shows us that stability often arrives quietly, without spectacle. The cosmos advanced not by force, but by balance. The deeper lesson remains subtle and universal. Foundations determine futures. Once the universe secured its basic structures, everything else became possible. From these particles came stars, Earth, life, and minds, capable of wondering how it all began. At this stage, the universe was still ruled by radiation. Photons carried most of the energy, constantly interacting with charged particles. Light did not yet illuminate space the way we imagine it today. Instead, it was trapped, scattered, and endlessly exchanged. The cosmos was bright but not visible. Matter existed, but it lived inside a sea of light. Protons and electrons collided with photons so frequently that no particle could travel freely for long. Space was filled with energy exchanges, a restless equilibrium that defined this era. The universe was active everywhere, yet transparent nowhere. This dominance of radiation shaped the future behavior of the cosmos. Energy flowed faster than matter could organize itself. Still, the presence of stable particles meant that this phase was transitional, not permanent. The universe was waiting for the right moment to let matter take the lead. What's fascinating is that light itself was already carrying information. Temperature differences, density variations, and tiny fluctuations were encoded in this radiant fog. These patterns would later guide the formation of galaxies and large-scale cosmic structure. The universe was quietly sketching its future. Even now, traces of this era remain detectable. Modern science reads these ancient signals to reconstruct the universe's earliest conditions. In future cosmic calendar episodes, when we explore the moment light finally breaks free, this radiation-dominated age will reveal its lasting fingerprints. Despite its intensity, this phase was remarkably orderly. Physical laws operated with consistency across the entire cosmos. This uniformity is why humanity can study distant regions of the universe and expect the same science to apply. Order preceded visibility. The universe was still young, but its direction was set. Matter had not yet won dominance, yet it was no longer threatened with extinction. The balance was shifting slowly, patiently, and irreversibly. The quiet insight here is enduring. Progress does not always look like clarity. Sometimes it looks like persistence beneath overwhelming conditions. The universe endured its brightest chaos so that one day it could become clear. Even in its earliest moments, the universe was never perfectly uniform. Minute fluctuations in energy and density existed from the very beginning. These variations were incredibly small, yet they carried enormous consequences. Without them, the cosmos would be smooth, empty, and forever uneventful. These fluctuations emerged naturally from quantum processes during the universe's infancy. Science shows that randomness at microscopic scales can shape structure at cosmic ones. What began as almost imperceptible differences would later grow into galaxies, stars, and the large-scale architecture of the universe. Creation favored imperfection. At this stage, matter and radiation responded differently to these tiny irregularities. Some regions became slightly denser, others slightly thinner. Gravity, though still weak, quietly began to amplify these contrasts. The seeds of structure had been planted long before Earth existed. The universe did not correct these fluctuations, it preserved them. Expansion stretched them across space, freezing them into the cosmic fabric. These patterns would guide the flow of matter for billions of years, shaping where planets could eventually form and where life might arise. This is one of the most powerful insights in modern cosmology. Complexity does not require large beginnings. It requires small differences allowed to persist. The entire history of Earth, its geological eras, and the story of life rest on this principle. Later, when we examine the formation of galaxies and cosmic webs in future cosmic calendar days, these early fluctuations will reappear as the invisible blueprint behind everything visible. Nothing grand appears without a quiet origin. What's striking is how gentle this process was. No dramatic explosion announced the birth of structure. It happened silently, governed by physical law and patient expansion. The universe trusted time to do the work. The enduring lesson here is subtle yet profound. Uniformity leads nowhere, but variation creates possibility. From the smallest imbalances emerged the vast, intricate cosmos we inhabit. As the universe kept expanding, a quiet shift began to take place. Radiation was still everywhere, but its dominance started to weaken. Matter, once fragile and easily erased, began to persist for longer stretches of cosmic time. This transition did not happen suddenly, it unfolded gradually. With each moment of expansion, energy diluted faster than matter. Photons lost intensity as space stretched, while particles retained their mass. This imbalance slowly tipped the scales. For the first time, the universe was moving toward a future where matter could shape destiny. This change mattered deeply for everything that would follow. When matter gains influence, gravity gains purpose. Structures can grow, interactions can last, and history can accumulate. Without this shift, there would be no planets, no geological eras, no Earth capable of sustaining life. The cosmos was still far from forming atoms or stars. Yet its internal hierarchy had changed. Matter was no longer a guest in a universe of light. It was becoming a resident. The rules of the cosmos had not changed, but their consequences had. What's remarkable is how subtle this transformation was. No cosmic alarm sounded, no dramatic boundary was crossed. Science reveals that the universe often evolves through quiet dominance rather than sudden replacement. Persistence, not force, defines long-term outcomes. This era also set the stage for gravity to become increasingly relevant. As matter accumulated, its mutual attraction began to shape future pathways. The large-scale structure of the cosmos traces its origin to this gradual rise of matter over radiation. In later cosmic calendar episodes, when we explore the birth of atoms and the release of light across space, this transition will stand as the turning point that made visibility possible. Matter needed time to claim its role before the universe could reveal itself. The deeper insight here is enduring. Influence grows through consistency, not speed. The universe didn't conquer radiation, it outlasted it. From that endurance emerged the conditions for planets, life, and humanity. As matter slowly gained influence, gravity began to step out of the background. It had always been present, woven into the fabric of the universe, but now it finally had something to work with. Mass could persist long enough for attraction to accumulate. The universe was no longer just expanding, it was beginning to organize. At first, gravity's role was subtle. It did not build stars or planets yet, but it started to favor denser regions. Slight differences in matter distribution became meaningful. Where there was a little more mass, gravity quietly encouraged there to be more. This process transformed tiny fluctuations into long-term trends. Regions that were once barely distinct began to stand out over time. The cosmos was learning how to remember its own irregularities. Structure depends on memory, and gravity is how the universe stores it. Radiation still resisted this process, pushing matter outward with relentless energy. Yet expansion weakened radiation faster than gravity weakened attraction. Slowly, gravity gained leverage. This balance would define the future architecture of the universe. Without this stage, the history of Earth would never begin. Geological eras, extreme events, and the origin of life all depend on gravity's ability to gather matter. Planets are not accidents. They are outcomes of patience written into physical law. What's striking is how non-violent this transformation was. Gravity did not force order instantly. It waited, responding only when conditions allowed accumulation. The universe favored restraint over immediacy. In future cosmic calendar episodes, when galaxies emerge and cosmic structures take shape, gravity will appear as the central character. Yet its true entrance happens here quietly, long before anything visible exists. The lasting insight is simple and powerful. Influence does not require dominance at the start. It requires endurance. Gravity waited until the universe was ready to listen. As gravity gained relevance, the universe entered a phase where form slowly became possible. Expansion continued, but it no longer erased structure as efficiently as before. Matter could now respond to attraction without being instantly scattered. The cosmos was beginning to hold on to its own patterns. Density differences, once fleeting, started to persist over time. Regions with slightly more matter resisted expansion just enough to matter. This resistance was subtle, but it marked a fundamental shift. The universe was no longer only stretching outward, it was developing internal tension. This balance between expansion and attraction defined the future of the cosmos. Too much expansion, and nothing would ever form. Too much gravity, and everything would collapse. Science shows that the universe sits delicately between these extremes, allowing complexity to unfold over billions of years. At this stage, there were still no atoms, no stars, no planets. Yet the framework for all of them was quietly assembling. The history of Earth, its geological eras, and the chain of life all depend on this early ability of matter to maintain shape against expansion. What's remarkable is that the universe did not need guidance or correction. Physical laws alone shaped this balance. Once established, they required no supervision. The cosmos became self-consistent, a system capable of long-term evolution. This era also reinforced the idea of scale. Small effects, given enough time, could influence vast regions of space. The universe was teaching itself how to grow without losing coherence. Growth and stability were no longer opposites. When later cosmic calendar episodes explore the rise of large-scale cosmic structures, this phase will stand as the moment when persistence became possible. Structure did not appear suddenly. It learned how to survive first. The enduring insight here is quiet but profound. Lasting forms are not forced into existence. They emerge when opposing forces learn to coexist. The universe didn't choose shape over motion. It allowed both to endure. As structure began to persist, time itself took on a new role. Earlier change happened too quickly for history to exist. Now processes could unfold gradually, leaving lasting consequences. The universe crossed from pure reaction into progression. Events no longer erased their own traces instantly. Cause could lead to effect, and effect could remain. This is when the cosmos first became capable of having a past. Without this shift, there would be no story to reconstruct, no science, and no history of Earth to study. Matter interacting under stable laws created sequences instead of moments. One state could influence the next. Time stopped being just a parameter and became a narrative dimension. The universe began writing memory into its structure. This development shaped everything that followed. Geological eras on Earth, biological evolution, and even human history all depend on the ability of systems to carry information forward through time. That ability was born here long before planets existed. The universe did not suddenly slow down, but it became readable. Patterns emerged that could be traced, predicted, and understood. Science is possible only because time preserves outcomes. The cosmos became legible to future observers. What's striking is how early this transformation occurred. The universe did not wait for stars or life to assign meaning to time. Meaning emerged naturally once stability allowed continuity. The foundation of memory preceded consciousness. Later cosmic calendar episodes will revisit this idea when we explore cosmic clocks, stellar lifetimes, and planetary cycles. All of them rely on this early shift, when time stopped dissolving into chaos. The lasting insight is subtle but essential. A future exists only when the past can endure. The universe learned how to remember, and in doing so made progress possible. As time gained continuity, predictability emerged alongside it. Physical laws were no longer just abstract rules. They produced consistent outcomes across the entire cosmos. The same interactions led to the same results. No matter where they occurred, the universe had become reliable. This reliability changed everything. Processes could now be modeled, anticipated, and repeated. What happened in one region of space would also happen in another under the same conditions. This uniformity is why science works, and why humanity can study the universe as a coherent system. Rather than a collection of accidents, matter responded to forces in stable, measurable ways. Gravity attracted, electromagnetism repelled or bound, and nuclear forces held particles together. These interactions no longer shifted unpredictably with each instant. The cosmos had settled into a consistent rhythm. This predictability allowed complexity to be delayed rather than destroyed. Systems could evolve step by step, building on previous states. The long road toward atoms, stars, planets, and life depended on this steady behavior. Without it, the universe would reset itself endlessly. What's remarkable is that predictability did not eliminate variation. Differences still existed, but they unfolded within boundaries. Order and diversity coexisted. This balance is what later allowed geological eras on Earth and the gradual emergence of life. The universe had effectively stabilized its own operating system. Once set, it required no intervention. From this point on, cosmic evolution became a matter of time rather than chance. Patience replaced fragility. In later cosmic calendar episodes, when we examine stellar life cycles and planetary formation, this predictability will reveal itself as the silent enabler behind every complex structure. Nothing evolves without dependable rules. The enduring insight here is simple. Freedom grows inside structure. The universe did not limit itself by becoming predictable. It empowered itself to evolve. By this stage, the universe had achieved something essential: patience. Expansion had cooled space enough for matter to behave consistently over long periods. Protons and electrons still moved freely, but the chaos that once defined every interaction had eased. The cosmos was approaching a threshold where true atomic structure would soon become possible. Although atoms had not yet formed, the conditions for their birth were taking shape. Temperatures continued to fall, densities thinned, and interactions slowed. This gradual cooling mattered more than any single event. It prepared the universe to move from particles toward chemistry, from motion toward structure. Electrons and nuclei still could not bind permanently, as energetic photons tore them apart instantly. Yet this struggle itself was progress. Each failed attempt carried information about what the universe was becoming capable of. Stability was no longer forbidden, it was only delayed. This moment connects directly to the future of Earth and life. Atoms are the foundation of molecules, and molecules are the language of biology. Without this slow preparation, there would be no origin of life. No planet shaped by geological eras, no humanity asking where it came from. The universe was learning restraint. It no longer forced interactions at impossible energies. Instead, it allowed processes to approach equilibrium. Science shows that creation often depends more on lowering intensity than increasing force. In later cosmic calendar episodes, when we explore the formation of the first atoms and the release of light into space, this phase will reveal its importance. Those milestones rest entirely on the conditions established here. Nothing appears suddenly without preparation. What's striking is how unremarkable this moment might seem from the outside. No spectacle, no visible structure, no light escaping freely, yet this quiet interval carried enormous consequence. Futures are shaped long before they become visible. The lasting insight is understated but powerful. Creation is often a matter of readiness, not action. The universe did not rush atoms into existence, it prepared itself to sustain them. At this point, the universe had done nearly everything required to allow atoms to exist. Particles were stable, forces were consistent, and time flowed with continuity. Yet one final condition was missing. Space was still too hot, too energetic, too impatient for electrons to remain bound to nuclei. Protons and electrons encountered each other constantly, drawn together by electromagnetism. But every attempt at union was immediately undone by energetic photons. The universe was close but not ready. This tension defined the era. Potential everywhere, fulfillment nowhere. What matters here is restraint. The universe did not force atoms into existence prematurely. It allowed physical law to dictate timing, not desire. Science shows that premature stability would have collapsed future complexity rather than enabling it. This waiting period shaped everything that followed. When atoms finally formed, they would do so across the entire cosmos at once, not in isolated pockets. Uniform readiness ensured a shared beginning, a common chemical language for all future structures. The history of Earth depends on this patience. Geological eras, oceans, atmospheres, and life itself rely on atomic consistency. A universe that rushed this step would never produce planets capable of sustaining complexity. The cosmos was not idle during this phase. It was refining conditions, lowering energy, thinning density, and aligning possibilities. Progress continued, even without visible change. This is how deep systems evolve. In later cosmic calendar episodes, the moment when atoms finally form will appear sudden and dramatic. But that moment only exists because of this long, quiet preparation. Breakthroughs are built on waiting. The deeper insight endures. Readiness matters more than speed. The universe waited until permanence could survive, and that patience shaped everything that came after. As the universe continued to cool, it approached a decisive boundary. Energy levels were dropping. Electrons would soon be able to remain bound to nuclei. The cosmos stood at the edge of transformation, a transformation that would change how it looked forever. For the first time, visibility was becoming possible. Until now, light had been trapped in constant interaction with matter. Photons scattered endlessly, unable to travel freely through space. This made the universe opaque, bright but blind. Yet the conditions sustaining this opacity were weakening with every moment of expansion. Matter was no longer fragile. Protons and electrons had endured long enough for cooperation to become inevitable. The universe had learned how to hold structure without destroying it. What remained was a final adjustment in temperature and density. This moment is critical for everything that follows. When light is finally released, the universe will gain a visual history. Science will later read that ancient light to understand the cosmos, the planet, and the path toward life. Visibility is what allows memory to travel. The history of Earth, its geological eras, and extreme events all depend on this turning point. Without light moving freely, there would be no stars to ignite, no planets to form, no environments to sustain life. Darkness was necessary before illumination could matter. What's striking is how quiet this threshold was. Nothing exploded, no new force appeared. A gradual shift in conditions unlocked a dramatic outcome. This is how the universe often works. Slow preparation followed by irreversible change. In future cosmic calendar episodes, the release of light will stand as one of the most iconic moments in cosmic history. Yet it is here, at this threshold, that the outcome becomes inevitable. The universe had already decided. The enduring insight is clear. Transformation begins long before it becomes visible. By the time change appears, it has already been earned through patience and balance. As the cosmos crossed this final threshold, it entered a phase where its future could finally be recorded. Conditions were aligning for light to travel, matter to endure, and structure to leave permanent traces. The universe was on the verge of becoming observable, not just existent. Memory was about to escape confinement. This moment represents a transition from internal evolution to outward expression. Until now, everything that happened remained locked inside dense interactions. Soon, information would begin to travel across space. Events would no longer vanish locally. They would announce themselves across the cosmos. Matter had earned this transition through patience and balance. Forces were steady, particles were stable, and time flowed predictably. Nothing new needed to be invented. The universe simply allowed consequences to persist. Science shows that revelation follows readiness, not effort. This shift would soon allow photons to move freely, carrying snapshots of the universe's state. Those ancient signals still reach us today, forming one of the strongest pillars of modern cosmology. Humanity reads them to reconstruct the earliest chapters of the cosmos. Everything that defines large-scale history depends on this moment. Galaxies, stars, planets, Earth, and life all require a universe capable of broadcasting its own state. Without that broadcast, complexity would remain isolated and silent. What's remarkable is how universal this change was. It did not occur in one region or another. It happened everywhere at once. The universe transitioned together, sharing a single moment of readiness across all of space. In future cosmic calendar episodes, when the first light fills the universe, this preparation will reveal its full significance. That iconic glow is not a beginning but a release. The work had already been done. The lasting insight is subtle and enduring. Meaning emerges when information can travel. The universe was about to speak for the first time, and everything that follows is an echo of that moment. At this stage, the universe had completed its longest preparation. Everything essential was in place, even though nothing dramatic had yet appeared. Particles were stable, forces were balanced, time was meaningful, and matter could persist. The cosmos had become a system capable of consequences. What followed from here was no longer uncertain. Once these conditions were secured, the universe's future unfolded with inevitability. Atoms would form, light would travel freely, stars would ignite, and planets like Earth would eventually emerge. The path toward life and humanity was no longer fragile. This is the quiet power of early cosmic history. The most decisive moments happen long before anything recognizable exists. Geological eras, extreme events, and even the origin of life depend more on preparation than on spectacle. The universe built its future invisibly. Science reveals that by this point, the rules of the cosmos were locked in. No later event rewrote them. Supervolcanoes, planetary formation, and biological evolution all operate within boundaries defined here. The universe chose consistency over improvisation. What's striking is how little drama accompanied such importance. No explosion marked this completion. No signal announced success. The universe simply became capable of sustaining complexity over vast stretches of time. When we explore later cosmic calendar episodes focused on stars, galaxies, and Earth itself, this era will remain unseen, but ever present. Every visible structure carries the fingerprint of these early conditions. The cosmos never forgets its foundations. This moment also reframes how we understand beginnings. Origins are not single instants, they are processes. The universe did not start life or planets directly. It started the conditions that made them unavoidable. The enduring insight is clear and universal. Futures are built quietly. By the time something appears inevitable, it has already been decided by patience, balance, and time. Before atoms, before stars, before Earth itself, the universe made its first irreversible decisions. In Day 4 of Cosmic Calendar, we explore the moment when pure energy transformed into the first fundamental particles. Quarks, leptons, photons, and forces emerged from the early cosmos, silently shaping everything that would follow. From galaxies and geological eras to life and humanity, these forces laid the groundwork for existence. This episode reveals how the universe cooled, stabilized, and learned how to persist. It explains why matter survived, how gravity began to matter, and why tiny fluctuations became the blueprint for all cosmic structure. Every planet, every extreme event, and every chapter in the history of Earth traces its origin back to these invisible beginnings. This is not speculation or fiction. It is science told through cinematic storytelling, grounded in modern cosmology, particle physics, and observational evidence. If you enjoyed earlier episodes about the Big Bang and the birth of time, this chapter connects them directly to the formation of matter itself. Watch until the end to understand why the smallest beginnings created the largest future. Subscribe to Cosmic Calendar, one day of the universe, and activate notifications to continue this journey through the cosmos, one day at a time.